Hello friends. Last in the last video I had talked about what is a label transition system and how it can be used to check the behavior of a system. Now in this video I'll be talking about a bisimulation relation which is used to compare two systems according to their behavior. That is, we compare the behavior of two systems. Now what exactly is this bisimulation relation? What does it tell from a label transition system? Now first we'll know what exactly is what is this bisimulation relation. So the bisimulation relation is something this um, consider that I have two label transition systems, say some A1 and A2 for and there is a state some S in A1 and S dash, and here I have some state T and T dash. For me to tell that S is related to T, that is there is a bisimulation relation between S and T, I should follow these rules. That is, if there is an action or a transition with an action A from S to S dash, then a similar transition from T to T dash should be there here also. That is, if S to S dash, if S to S double dash, there is some other B, then T to T dash also I should have T to some other state. It may be like T triple dash. I should have a B. If S2 there's some state like S1, if I have a C, then there should be a state from with the transition and action C to some other state like T1. So if there is a transition with an action in one LTS, then there should be an equivalent transition for that action in another LTS. This is the first condition of bisimulation relation. The second condition is just the vice versa. Second condition is just vice versa. If there is a transition from in the second label transition diagram, if it is like T A to A dash, I should have in the first transition diagram also A to S dash. So the same thing follows here. What we studied in the first, what we had learned from the first rule, same thing. If there is some B to some other T1, then there should be a B to some S1. So we should check both the outgoing, we should check the outgoing transitions in each state in both the transition system, label transition system. If all the states in label transition system A1 are having a bisimulation relation with all the states in transition system A2, then we can tell that there is the behaviors are equivalent. Let me take an example for that. I've already drawn an example. Yeah. Consider this label transition system. I will take this as A1 and this as A2. Tell me whether these are equal, whether these label transition systems give the same behavior. Oh sorry, I have left two things. This is a B action, here also there's a B action. Now, now let us consider with the given rule that if there is a transition from S to S dash with the A, then I should find a same transition in from T to T dash. Okay, let me see that. For S1 and T1 to be to have a bisimulation relation, I should check the outgoing transitions, that is the actions what it performs to go to the other state. So let me take it. So S1 has a transition to S2. T1 has a transition to T2. Okay, so this is done. Then let me change the color. S1 has a transition to S3. T1 has a transition to T2. So I can use the same transition because this depending on this action. If the action is same, then there's no problem to use the same transition here also. For two transitions in A1, I can use a single equivalent transition in A2. There's no problem with that. But there should be a transition for that action from T1 to T2. Okay. Now this part is done. Now let me come to the second level here, this level. Again, let me consider S2 makes a transition to S4, a B transition to S4. So S2 makes a B transition to S4. T2 makes a B transition to T3. Okay, done. Can I tell S2 and T2 are equivalent? No, because I have left one transition in T2 to T4 in A2. So let me consider that. T2 makes a B transition to T4. S2 makes a B transition to S4. Now I can tell that there is a bisimulation relation between S2 and T2. For two systems to exhibit same behavior, all the states should satisfy the bisimulation relation. So I should check the bisimulation relation for S3 also. So let me consider S3. S3 makes a B transition to S5. T2 makes a B transition to T3. Because I was in this level, here also I should check that level. After making a transition, here also after making a transition, I came to S3. In this, I made a transition and came to T2. So I should check from T2. So S3 makes a B transition to S5. T2 makes a B transition to T3. Can I tell S3 and T2 have a bisimulation relation? No. I should check for the outgoing transition from T2 again. So T2 makes a B transition to T4. I can use this again as S3 makes a B transition to S5. Now I tell that S1 is related to T1, S2 is related to T2, S3 is related to T2, S5. Now S1, S2, S3, S1, S2, S4 and S5. So S4 has no transitions, T3 also has no transitions, S5 has no transitions, T4 also has no transitions. So S3 to S5 comes. So here both have no transition. I can use anything. Yes. Let me draw it again if you want. So S4 after S2 to S4, T2 to T3, no transition. Okay. S3 to S5, this one, no transitions. So I'll take S4 is related to T3 and S5 is related to T4. So all the states are related. There is a bisimulation relation. These are some bisimulation relations. So these are equivalent based on bisimulation relation. Let me see what behavior A1 and A2 exhibit. Let me take a different color. A1 exhibits a behavior which is like action A followed by action B, action A followed by action B, or action A followed by action B, action A followed by action B. Now what does A2 exhibit? Action A followed by B or B, B or B. This is the behavior exhibited by A2, and this is the behavior exhibited by A1. As we can see, these both we can tell that these are equivalent, because see, after I do A, I can do a B. After I do A, I can do a B. After I do A, I do a B or a B. So there is no problem. Both are equivalent. That is, in both cases, I can do a AB. I'll take another example where the bisimulation equivalence fails. I have just changed one action in the previous label transition diagrams. That is, instead of B, I have used a C action here. Now let us see whether these exhibit the same behavior. So let us start. I'll do it fast this time. A bit. Okay. So S1 exhibits a S1 has a transition to S2, T1 has a transition to T2. No problem. S1 has a transition to S3, T1 has a transition to T2. So S1 is related to T1. Now let me consider the second part of this. S2 has a B transition to S4, S2 has a B transition to S4. I'll use some other color. T2 has a B transition to T3. Now, can I tell S2 is related to T2? No. I should check for this outgoing transition. So let me check. T2 makes a C transition to T4, but there is no C transition by S2 made to some other state. There is no C transition. So S2 is not related to T2, but it should have been related. So these two label transition systems are not equivalent. That is, they do not exhibit the same behavior. But they look the same. Let us see what behavior they exhibit. Let's see what behavior they exhibit. Now let me consider this label transition system as A1 and this as A2. Now first I'll see what A1 is. A1 says that it has a B or a AC. So A1 has like AB or AC. Okay, what does A2 exhibit? What behavior does A2 have? It has something like A or A followed by B or C. This is what A2 gives. A2's behavior is. So aren't they equal? Aren't they same? We saw that in the previous it was same, but here there is some problem. Let me tell you where the problem is. Assume that I make a transition here. I make a action. Okay. Here I want to make a C action. Is it possible here? Actually, I don't have a C action here. It is not possible to make a action. It is not possible to make a C action once I make a action here. But let me check in this one. Here I make a action. Now I feel that I want to make a C action. Yes, it is possible. So I can't tell that these two exhibit the same behavior. This is the main problem. But you may think that in the previous example also that was the same case. But let us see what the previous example said. Now let me consider the same thing. I want to make a action, and then there is no C here in both the cases. I can choose B, B. So out of B I choose B. I can do a B action. I want to make a action followed by a B action is the only one I can choose. So these two label transition systems exhibit the same behavior, that is AB. But here in this example we should make a right choice. Sorry, what is this? Yeah. We should make a right choice in advance itself. So if we make a choice here, then there may be a chance that we have made a wrong choice in the transition, because I can't make a C action here. So this is how we can check whether the two label transition systems exhibit the same behavior using bisimulation relation.